So today we're in section 9.1, example 5. Just one example still to cover today. This example involves solving equations with a square root. So before we get to that slide, I just want to do a little bit of review with you on just solving equations in general. To solve equations, we use opposite operations. So if we had an equation like 2x equals 10, how would I solve for x? This is as most basic as it gets, guys. Divide 2 both sides, okay? So divide 2 both sides, and you get x equals 5. The principle here, guys, is that we're using opposite operations to solve equations. So yesterday, we learned about square roots. Let me get back to example 5. And with square roots, okay, basically, we learned that the opposite of an exponent is to take the what? Take the square root of that number. So if a number is raised to a power, taking the square root of that number takes that perfect square factor out. For example, the square root of 36 is what? 6, okay, because that's the number that can be multiplied by itself to equal 36. All right, so what we're going to do, and actually this is not the first slide that I want to cover. Let me get over to this one. Okay, so what we're going to do in this example is we're going to solve equations that need a square root because there's an exponent attached to our variable. So in order to get a by itself, it's raised to the second power, so I'm going to take the square root of it to solve. So whatever I do to one side, I'm going to do the same thing to the other side. So I get a equals, what's the square root of 9? 3. Now we have to explore the sign of our answer, okay? So going back to the original problem, we know that 3 times 3 is 9, okay? So that works out. But what about negative 3 times negative 3? Does that equal 9?
Yes, it does.
Yes, it does. So because of that, my answer can be both positive and negative and still make the equation true. So that's why whenever I solve equations involving square root, my answer is both positive and negative. We'll talk more about that in just a minute. Okay, let's go ahead and I want you to try to work number 2. All right, so I'm going to take the square root of n squared and the square root of 25. And who got n equals positive negative 5? Who got that? N equals positive negative 5? Everybody get that? Go ahead and do number 3 now. All right, so I'm just taking the square root. In order to get rid of my exponent of 2, I can do the opposite operation, which is taking the square root. Okay, so square root both sides, square root of 400, square root of y squared, and y equals positive negative 20. All right, now let's look at number 4. Number 4 is not a perfect square, meaning if I take the square root of 20, it's not going to be an even number. So in this scenario, I still have to take the square root to solve for m, to get m by itself. But I'm going to need to approximate my answer to the nearest tenth. So when we take the square root of 20, we change it to a decimal, hit the S to D button on your calculator, and round to the nearest tenth. Go ahead and write your answer. What was it? 4.5. What was it before you rounded though? 4.47. Yeah, that's what I thought. It was 4.47, and then yes, you round it to 4.5. Okay. All right. Who got that right? Rounding to the nearest tenth. Okay, so really not a big deal. Okay, so we have one more slide. Now, on this slide, you're going to have other terms in the equation. Let's see. We've got, is this what I want? Yeah. Okay, so we've got 5y squared equals 110. Yeah, we forgot. Let's switch back real fast. Yes. Positive negative 4.5. Positive negative 4.5.
When you're out to the nearest tens, you still have to.
Yes, absolutely, absolutely. So we just forgot that. So thank you for pointing that out. All right, now let's go to the next slide. Okay, so we've got several terms in here. 5y squared equals 110. The square root is the last thing I do. So I don't start by taking the square root because I've got that 5 in there. So instead, what am I going to do to get 5 to cancel to the other side? Divide by 5, okay? So we start off by dividing by 5 both sides. Now I have y squared by itself equals 25, or I'm sorry, not 25, but 22. All right, that's okay. If it's not a perfect square, don't think, oh no, I did something wrong, okay? So what do I do now? What do I do next? Take the square root of both sides. And y is approximately 4.7. I still need to just do that rounding to the nearest tenth. Go ahead and try number 2. Okay, I forgot the positive and negative again. See how easy it is to forget? Okay, and I'm going to leave this on the recording. I'm not going to redo it because it helps you know, okay, I'm not perfect, yes, but we do need to include it. Even when we're rounding to the nearest tenth, we've got to include it because it's still true. Negative 4.7 times negative 4.7 is positive 22, okay, approximately. And then when I multiply by 5, it still works out. It's still a solution. All right, so on number 2, I divide both sides by 0.5, and then I get t squared equals 324. Take the square root, and t is approximately, not approximately, it's exactly positive negative 18. Positive negative 18. Okay? All right, number 3. Number 3 has now even more terms in the equation, but I still follow just my steps for solving an equation, and I save the square root for last. Go ahead and do number 3. So yes, you need to move what's not connected to the variable first, that whole term. So you're going to subtract 1 first, and then you get 2a squared equals 97. Now we're kind of back to where we were in number 1. What would we do next? Divide both sides by 2. You get a squared equals 48.5. Well, that's not a perfect square, but that's pretty stinking close to what perfect square? No, 49. 49 is a perfect square, so you know it's going to be really close to 7. All right, so when we take the square root of both sides, 6.96. So what's going to happen when I round this? Yeah, the 6 bumps the 9 up to a 10, but because it's a 10, it actually bumps the 6 up to a 7. So A is approximately positive and negative 7. Okay, Greg, is that making more sense? Myri?
Okay, so when you did the 48.5, can you just round 5?
No, you don't. Okay, that's a good question. You don't want to round anything until you get to your answer and you round to the nearest tenth. If you round too early, it's going to throw off your answer. Okay, good question. I mean, that would be nice, right? Because then it's just the square root of 49 up there, but then you're going to think that the answer is exactly 7, but it's not. So you're going to write an equal sign when it should be approximate. Okay, so do not round until you get down to your final answer. All right, if you understand that, that's everything you need to know for section 9.1.